Welcome to our capacity building lessons on smart microgrid and system integration. My name is Fanny Smokera Umbati. I'm an urban energy officer working with UN Habitat. I'll take you through lesson 3 on climate proofing sustainable energy solutions. This is part of the Smart Energy Solutions for Africa project. In this video, you will learn what climate proofing for sustainable energy solutions is, how to implement climate proofing for solar mini grids, and the basics of financing and risk assessment for scaling up climate proofing. We will discuss climate proofing measures for sustainable energy solutions, including solar mini grids, addressing the risks they face from climate change, and the crucial steps needed to ensure their resilience and effectiveness. As we proceed, it's very important to familiarize with the term climate proofing. Climate proofing is a process that identifies risks to an asset as a result of climate change and variability and ensures that those risks are reduced through long-lasting and environmentally sound, economically viable, and socially acceptable adaptation measures. Climate proofing involves the integration of possible risks caused by climate change into policies, project planning and design. The benefits of climate proofing is it creates economic opportunities and ensures energy security in the face of climate change impacts. Climate change poses risks to infrastructure and value chains, and this can include energy, mobility, telecommunications, and water. Therefore, climate proofing is very vital for the success of energy transition in Africa. We're going to focus on climate proofing of solar mini grids, and we're going to look at the components of solar mini grids, including the possibilities of climate proofing risks from climate change specifically for solar mini grids. Towards climate proofing, key sustainable energy solutions face climate-related risks. When we're talking about sustainable energy solutions, this includes e-mobility fleets, solar mini grids, clean cooking, productive use of energy appliances, and e-waste from solar off-grid solutions. There are also interdependencies among different types of infrastructure, for example, between energy and water or energy and mobility. If one infrastructural asset is negatively affected by climate change, this can lead to a cascade of impacts through the system. Solar mini grids are composed of a set of solar electricity generation and storage devices that are connected to a distribution network. Climate proofing measures include choosing appropriate PV panels and batteries for solar mini grids. It's key to note that mini grids can be operated and controlled independently from the main grid. It's key to note that while solar PV systems are the most common generation technology used in African mini grids, other renewable energy resources such as micro hydro turbines, biomass, or small wind generation units can also be used to generate power. The diagram here shows the key components of solar mini grids, and this includes power generation, production, and distribution to the end user. In terms of storage, this component absorbs the surplus power during off-peak hours and dispatches stored energy at times of high demand. In terms of distribution systems, this is composed of distribution lines which can be either overhead or underground and includes pole protections and transformers if needed. Energy management systems, often coupled to digital tools, control and monitor electrical loads. This includes the charge controller that connects the solar panels to the inverter or the battery. We're going to look at climate change risks and possibilities of climate proofing, focusing on solar mini grids. I'm going to give examples of risks from climate change and the possibilities for climate proofing for each. The first one is reduced efficiency of PV panels due to excessive heat. For this risk, the choice of PV panels should be suitable for expected temperature variability. That is, with small temperature coefficient where efficiency is not greatly reduced under high temperature. The other one is disruption or reduction of vital ICT services due to damage to telecommunications network. For this specific risk, the design of ICT and IoT components should be resilient and adaptable. The other risk is physical damage caused by flooding, wind, landslides, and fires. For this, the choice of sites that takes into consideration the climate risk in the specific location should be considered. While implementing climate proofing, climate risk assessment should be integrated into each project development steps. That includes planning and strategies, feasibility studies, technical design, and operation and maintenance. Climate proofing is more effective and less costly when it starts at an early stage. When you're talking of early stages, we mean project planning and design. Integrating climate proofing into the financing and business models of sustainable energy solutions is very crucial, as the process can increase the complexities of design and therefore the upfront costs and financing needs. We need to also ensure that we allocate sufficient resources, create the most appropriate working team, and ensure compliance to applicable legislation and regulations. Scaling up. Scaling up is very crucial for the widespread success of sustainable energy solutions. Accelerating this process requires reliable climate change impact projections and also risks assessments that provide essential data for policymakers and businesses. Also, key to note is the availability of financing. Approaches such as loans, grants, debt relief, and blended finance can support climate change adaptation. When we're talking about blended finance, this is a combination of public and private financing, and these are typical approaches for climate adaptation financing, which can be tapped into by businesses aiming to climate proof energy solutions. Here are some additional resources that you can refer to. We've come to the end of our lesson. Thank you for your time. I hope you found this lesson useful.